Hey everyone, welcome back to my channel. In this video I'll be talking about the steps of RCT. So this is the basic outline. Diagnosing the case. So proper diagnosis should be done to decide whether the tooth needs RCT, whether DPC or IPC is needed, or whether simple restoration will do the work. So for better understanding of this, please watch the part 1 of the video on basics of RCT. In that video I have explained under what circumstances we have to do the simple restoration or DPC or IPC, or when RCT is actually needed for the tooth. So after diagnosing that this tooth needs RCT, what will be the steps? Isolation and pre-endo build-up. Isolation, we know that for isolation rubber dam is the gold standard, but in case of unavailability we can use the cotton rolls and suction. Then pre-endo build-up. What is pre-endo build-up? This is the build-up which is done before the excess cavity preparation, and this is done for the walls which are missing. If a wall of the tooth is missing due to caries or any other cause, we have to build it up before doing the excess cavity preparation, and this is called as pre-endo build-up. Then excess cavity preparation, working length determination, cleaning and shaping, obturation, and post-obturation restoration. So let's understand the steps with an example. This is an incisor, and here it has only one canal. Our first step will be the excess cavity preparation. So we will locate the orifice of the canal. Then what will be the next step? First step is excess cavity preparation, and then we will do the working length determination. Now what is working length? Working length is the distance between the coronal reference point. If this is the reference point, distance between this reference point to the point where the preparation or obturation will terminate is known as the working length. So this distance is the working length. The distance between the coronal reference point to the point at which the canal preparation and obturation terminates is known as working length. So how do we decide which point? So this is the point where the preparation will terminate and obturation will terminate, and this is the point. This is the minor diameter or apical constriction. So let's understand the concept of major diameter, which is also known as apical foramen, and minor diameter, which is known as apical constriction. See, this is the most constricted part and is therefore known as apical constriction and is the minor diameter. Okay, the most constricted part is the apical constriction or minor diameter, while as this one is the main opening or exit point of the vessels and is known as major diameter or apical foramen. So the main opening of the vessels, main exit point of the vessels is the minor diameter or apical foramen, whereas the most constricted part is the minor diameter and apical foramen, also known as apical foramen. This is the point where CDJ is located. CDJ means cemento-dentinal junction. So this is the point where CDJ is located, where minor diameter or apical constriction, and this is the point where the canal preparation should terminate. Okay, canal preparation should terminate at the CDJ. Okay, this is located 0.5 to 1 mm short of the, this is located 0.5 to 1 mm short of the apical foramen or the radiographic apex. This is mm, not nm. So this is all about the major diameter, minor diameter, and the point where the canal preparation should terminate is the CDJ, that is cemento-dentinal junction, minor diameter or apical constriction. Let's repeat. Working length is the distance between the coronal reference point and the point where the canal preparation or obturation should terminate, and that very point is the apical constriction, CDJ, or minor diameter. Okay, so this is the working length. Now we have to determine this, that is we have to measure this working length. So we will use, let's suppose, 10 number file. Okay, with the stopper we will place this file inside the canal, take the radiograph, and then find the working length. We can use different methods. There are different methods for locating the working length using the radiographs, Engel's methods, Grossman method, or we can use electronic apex locators. There are different methods besides radiographs, electronic apex locators, which we will study in the coming videos. So basically we studied about the working length. What is working length? Working length is the distance between the coronal reference point to the point where the preparation should terminate, and that point is the apical constriction, CDJ, or minor diameter. That point is known as the minor diameter, apical constriction, and that is CDJ. After working length determination comes the cleaning and shaping. This is the very important step. See, we know in excess cavity preparation we have to locate all the canals. If we miss the canal, then it will be we won't clean it, then the RCT will eventually fail. Now, what if we have already located the canals but we fail to clean them properly? Then also RCT will fail. So cleaning and shaping is very important in the RCT. Remember that the instruments shape, that is the files which we use, they shape the canal, while irrigants clean. Irrigants as in sodium hypochlorite, EDTA, these are the irrigants which we use. These clean the canal. So we have to use the irrigants along with the instruments to clean and shape the canal, and this is very important. Okay, success of RCT depends on it. Then after proper cleaning and shaping and placing the intracanal medicaments, we finally go for obturation. Okay, obturation we use the GP, we will study about it in the coming videos. Then post obturation restoration. So we already studied about the outline. Then coming on to the excess cavity preparation. Excess cavity preparation mein, first of all we'll study about the laws of excess opening. So law of centrality. The floor of the pulp chamber is always located in the center of tooth at the level of CEJ. So what does this mean? If this is the tooth, okay, now this is the cemento enamel junction. Law of centrality says that the floor of the pulp chamber, okay, see, this is the roof of the pulp chamber, this is the roof, and this is the floor. So law of centrality says that the floor of the pulp chamber is located in the center of the tooth. It is located in the center of the tooth, but where? In the center of the tooth at the level of CEJ. So this is the law of centrality. Then comes the law of concentricity. The walls of the pulp chamber are always concentric to the external surface of the tooth at the level of CEJ. So law of concentricity says that if this is the tooth and this is the pulp chamber, law of concentricity says that walls of the pulp chamber, if these are the walls of the pulp chamber, they are always concentric to the external walls of the tooth surface. So we know concentric circles, so this is like that. The walls of the pulp chamber are always concentric to the external surface of the tooth. So this is the law of concentricity. Then comes the law of CEJ. This is basically the law of concentricity, but what we have to note here is that the CEJ is the most consistent repeatable landmark for locating the position of the pulp chamber. See, the distance from the external surface of the clinical crown to the walls of the pulp chamber is same throughout the circumference of the tooth. This is what concentricity is at the level of CEJ. But where is it? Where is it concentric? It is concentric at the level of CEJ. So the CEJ is the most consistent repeatable landmark for locating the position of the pulp chamber. If this is the tooth and this is the pulp chamber, and this is the cross section at CEJ. So law of CEJ says at the level of CEJ, the distance from the walls of the pulp chamber to the external surface of the tooth is same throughout. If here the distance is A, here also the distance will be A. Here also the distance will be A. So this is the law of CEJ, that the distance from the walls of the pulp chamber to the external surface of the tooth are same throughout the circumference of the tooth. यहाँ पे हर जगह the distance will be only A. And this is the law of CEJ. Then comes the law of symmetry 1, law of symmetry 2. In both of these laws there is an exception. An exception is the maxillary molars. So except for maxillary molars, law of symmetry 1 states that the orifices of the canals are equidistant from a line drawn in mesiodistal direction through the pulp chamber floor, and the law of symmetry 2 states that except for maxillary molars, the orifices of the canals lie on a line perpendicular to the line drawn in mesiodistal direction across the center of the floor of the pulp chamber. Let's understand this. If this is a mandibular molar cross section, this is the mesial, this is the distal, this is the buccal, and this is the lingual. And if this is the, okay, let's say if it has only one distal canal, this is the mesiolingual, this is the mesiobuccal canal. Okay, so except for maxillary molars, the orifices of the canals lie equidistant from a line drawn in mesiodistal direction. So this is the line which is drawn in the mesiodistal direction. The orifices of the canal are equidistant. So the distance from this line to this orifice is equal to the distance from this line to this orifice. Okay, if this is the line drawn in mesiodistal direction, the distance from the orifices are equal from the line drawn in mesiodistal direction. Then comes the law of symmetry 2. It states that the orifices are located at a line perpendicular. Okay, the orifices are located at a line perpendicular. So if this is the perpendicular to the line drawn in mesiodistal direction, the orifice will be located to its perpendicular position. After law of symmetry, there is the law of color change. Law of color change states that the color of the pulp chamber floor is always darker than the walls. See, if this is the tooth, the one drawn with yellow will be the dentine. Okay, this is the dentine because dentine is yellower. Then let's say if this is the enamel, then there will be the pulp chamber which is grey. Okay, the floor which is grey, and the orifices are black. Okay, so law of color change states that the color of the pulp chamber floor is always darker than the walls. the color of the pulp chamber floor. This is the floor of the pulp chamber. It is darker than the walls. The walls will be darker and the pulp chamber floor, which is usually of the grayish hue, it will be darker than the walls. Then Law of Orifice Location. Law of Orifice Location 1, Law of Orifice Location 2 and Law of Orifice Location 3. Law of Orifice Location 1 states that the orifices of the root canals are always located at the junction of the wall and the floor. So, the orifices are not located at the wall or the floor but at the junction of wall and floor. In the Law of Orifice Location 2, the orifices of the root canals are located at the angles of the floor-wall junction. One states that the orifices are located at the junction of floor and wall, and then the Orifice Location 2 gives the more precise location and states that the orifices are located at the angles in the floor-wall junction. And the Law of Orifice Location 3 states that the orifices are located at the terminus of the root developmental fusion line. So let's understand the Law of Orifice Location. See, if this is the wall and this is the floor, this is the wall, this is the floor, pulpal floor, let's say. So the Law of Orifice Location 1 states that the orifices are located at the floor wall junction. So it is not located here, यहाँ पे नहीं है, floor पे नहीं है, but at the junction of floor and wall. This is the Orifice Location 1. And then the Law of Orifice Location 2 states that orifices are located at the point angles. We know line angle is the junction between two surfaces. Okay, line angle is the junction between two surfaces and the point angle is the junction between three surfaces. This drawn with green is the point angle. It is the junction between this and this surface. So Law of Orifice Location 2 states that the orifices are located at the point angles in the, if this is the wall, this is the floor wall junction के point angle में the orifice will be located. This is all for today. I'll be continuing with the excess cavity preparation and rest of the steps in the next video. Thank you.